Okay, so in this lecture, we're going to look at how to work out the gradient of a line when you only have the angle it makes with the x-axis. So how can we work this out? Just say we're given this line AB and we don't have any information about x1, y1, x2, y2. So how do we work this out? Well, we could have a look at the gradient formula, which we usually do, is equals y2 minus y1 over x2 minus x1. Well, that's not much use because we don't have any information about the positions of x and y. So what other properties do we know about triangles? You know, you could think back to trigonometry, and you could think back to SOHCAHTOA. So H, C, A, H, and T, O, A. So do we have any information about the opposite or the adjacent or the hypotenuse? And what you might spot here is we actually know information about the opposite side because that's just the difference in the two y points. So you could say the opposite is equal to y2 minus y1, and going with that, we've also got information about the adjacent. So GD equals x2 minus x1. So we've got information about the opposite and the adjacent. So that means we might be able to use this expression for tan. So what's the expression for tan? So it's tan equals tan of theta equals the opposite over the adjacent, J. And if you look back here, you'll see that the expression for m is equal to y2 minus y1, but we already said that the opposite is equal to y2 minus y1. So you could put the opposite there as well. And then m x2 minus x1, which we also said is equal to the adjacent. So AJD. And we know from here that this is equal to that. So opposite over hypotenuse is equal to tan theta. So you can just cancel this middle part out, and then you can say that your gradient is equal to tan of the angle theta that it makes with the x-axis. So we're going to just do a quick example to cement this in. So you've got a gradient, what is the angle of the gradient of the line AB? So again, all we have is this information of the line. And from our previous slide, we know that the m is equal to the tan of the angle theta, which in this case is tan of 45, which you need to put this in a calculator, or you might know this, which comes out to be 1. So the gradient of the line is 1. So m AB equals 1. Great. So I hope you now understand where that tan theta m equation comes from. Thank you.